Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, there is real excitement building around space at the moment, but today I wanted to learn a little bit more about the technology that is up there floating around in orbit and playing an essential part in connecting the world. For example, there will be an estimated 40 billion connected devices by 2025. But a big limitation to fulfilling the potential of this tech is the fact that 90% of the world's surface doesn't have access to cellular service or Wi-Fi. And yes, while there are existing satellite data services like Starlink, which are rapidly growing, those services are incredibly expensive for IoT device users and manufacturers who don't require high-speed, high-cost connectivity. So the people that don't need that, where do they go? Well, a new Silicon Valley satellite tech startup called Swarm is addressing these issues by developing a low-bandwidth, low-cost service that commercially launched in February. And this service is ideal for a wide range of IoT use cases in industries ranging from agriculture to logistics to maritime to transportation. And they were founded in, 2016, but they're committed to making data and communications accessible to anywhere on this planet for just $5 a month. How cool is that? But I've probably revealed too much information already, so buckle up and hold on tight as I beam your ears all the way to California so we can speak with Ben Lomgmeir, who's waiting to speak with us now. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, my name is Ben Lomgmeir. I'm the CTO and co-founder of Swarm Technologies. We are a small startup in Silicon Valley out here in California, and we launch and deploy small satellites into space for communications.
And every startup has a story behind it, and I'm always fascinated to hear more about the origin story of the guests on the podcast. So I've got to ask, where did your love of technology come from, and what was it that put you on this path you're on today?
Oh man, I've always loved technology, always taking things apart as a kid and putting them back together, mostly into a functional state again. And, I always had a love of space as well. And, all through school had worked on a number of, fun and interesting technologies, did some degrees in physics and nuclear engineering, and was always in the lab and tinkering around. So Swarm was born out of a desire that Sarah and I had, my co-founder and I had, to bring super low cost connectivity to the world. And this is something that didn't really exist before we came along. It was sort of impossible to deploy satellite modems around the world at a cost where you kind of don't think about it anymore. You of course choose to put a satellite transmitter on some sort of GPS device that's on the middle of a ocean, recording the temperature of a cargo container that's carrying, vaccines around the world, and you want to make sure that that temperature never gets too high or something, or monitoring the soil moisture in a field that is recording, optimal crop health, and you don't want to waste water. And it's applications like these where in the past you couldn't really afford to do that with every single thing that's moving around the world or that wants to be monitored. But I think you can now with the stuff that we've been rolling out.
And what I find fascinating here is there's two sides of the tale here, isn't there? On one side, there's going to be an estimated 40 billion connected devices by 2025. But a big limitation to fulfilling the potential of technology like this is the fact that we don't talk about often enough, and that is that 90% of the world's surface doesn't have access to cellular service or Wi-Fi. And yes, there are existing satellite data services such as Starlink that are rapidly growing their services, but they are expensive for IoT device users and manufacturers who don't require high-speed, high-cost connectivity. So I'm curious, can you expand on that just to set the scene? Because I think it's something we don't talk about enough, and it's a big problem, isn't it?
Yeah. So kind of two ideas there, really. First of all, we're humans, right? And our human experience is mostly around other humans. And that means, we spend most of our days in cities, we spend most of our time commuting on roads. And, by and large, these are areas that we have on purpose set up infrastructure on. And we have communications infrastructure at home, we have that at work, we have it in cities, we have, Wi-Fi that's wireless, we have cellular that's wireless. But again, most of these technologies are where people are. And that makes sense. That makes total sense. That's where you want them. But as soon as you start venturing off the beaten path, as soon as you take a backcountry, hiking trip, or as soon as you send something across the ocean or across, even some remote highways in the US or Alaska or that kind of thing, then you very quickly meet areas where there isn't Wi-Fi and there isn't cell connection, and you kind of have nothing. So one of the pretty unique things about what Swarm is trying to do is to bring that super low cost access of satellite data connectivity, not voice for now and not video for now, but just really important pieces of information. So, for example, we're working with a few car manufacturers that they want to put a little beacon into the truck or into the car. If if your airbag goes off, or if your tire pressure gets too low and the tire goes low, and you're in a really remote place and you don't have cell service and you can't call for help, well, your car can ping for help and someone can then show up and help you out. And we think of the data infrastructure in a synergistic way, meaning a lot of these really big companies like SpaceX that's doing Starlink, OneWeb, Amazon that's doing Project Kuiper, and another company called Telesat, they're trying to bring broadband to the world, and I like that. We really like that. That's a very good service. Schools and remote locations should have broadband. If you're in a remote, village in northern Canada and don't have access to fiber or DSL or something, you should have broadband. That's a great helpful tool. And I always use the analogy like there's a time and a place when you want to be at home streaming Netflix, and that's a high-speed connection. But there's a time and a place when you want to have a battery-operated device, i.e. a cell phone or some sort of other portable device, out in the middle of nowhere, and you want it to be able to text. So, we kind of use the analogy that Swarm is the texting or the data service that is mobile, and you don't have to plug it into a wall, but it provides those little bits of information, GPS data, texting data, sensor data from machines all around the world.
So essentially, who is your services aimed at? Is it the humans that we're talking about here? Is it big businesses or companies? And, who primarily are you aimed at here?
Yeah. So we decided that we wanted to roll out and first aim ourselves at providing machine-to-machine data around the world. So we find a lot of customers that are on our network now. Our network is commercially live, and we find a lot of our customers are in the smart agriculture space, for example, and they want to bring back, what was the water flow sensor, or what's the tank level, at today. And these are things where if you're growing crops, you're kind of in a low margin business. It's not a huge Silicon Valley tech kind of thing, and you want to make sure that you're able to provide that data in a sensible way, in a way that you can read it, and in something that doesn't break the bank. So before Swarm, you had to pay about $1 per, little data ping, $1 per text message kind of equivalent. And I don't know about you, but I can't afford to pay $1 per text message just walking around in life, and neither can these agriculture sensors. And so you need to keep these costs, pretty modest. And so we've tried to, price our data services so that all of that makes sense, and that's a sensible business. So we find that's one of our primary applications. Our other primary applications are things that move, and things that move on the ground, on land, things that move in the ocean. There are many of those devices that, from time to time do want to be tracked. So for example, we find that even, with our car manufacturers, we find that even in their logistics chain, they want to track, okay, I sent 100,000 axles from this place to this place to this place around the world, because many of these places are global manufacturing units. Where are they? Let me track my supply chain so that I can, better optimize when parts arrive and when they're stalled and when they're missing and so on. And right now that's not done. That seems crazy, but that's not done. So it's kind of this guessing game of, how do I best optimize my supply chain to save billions and billions of dollars over the net run of the business. But I think that's where Swarm can add some real value is adding those little bits of data, around the world.
And before you came on the podcast today, I saw on your Twitter feed, I think over 10 million data packets have been sent across the Swarm network. That's incredible, isn't it?
Yeah, we're pretty happy with that. We've had this network live since the beginning of this year. We're actually still building it. We have a couple of more launches left later this year, and then we'll be complete. We'll have 150 satellites up in space. These are all in low Earth orbits, so they move, and they're in polar orbits. So it's kind of like the constellation looks like a slice of orange wedges. So if you put all those wedges together, they make a complete coverage circle. And by the time we deploy, we'll have, on average, 3 satellites overhead every point on Earth at all times. So someone can, transmit at any point in the day, at any point on Earth, and they'll have a message be able to go through the Swarm network. And so we like this 10 million, number now. We're excited that many people have transmitted data from all continents now, really. So that's been exciting for us to see that growth. And it's been hard. It's been a long journey to, get funding, get access to spectrum, grow the team, grow the technology, develop the technology to a mature state where things are reliable in space and functional, and things are reliable on the ground. We set up all of our own ground stations around the world to bring that data back to the internet, and to do all the normal cloud services too that a modern user expects to have. So we have these API interfaces where people can get really easy access to their data.
It's incredibly cool technology, and we will have people listening to this podcast today and your words in every single continent on the planet. So I'm curious, for people that are hearing about you for the first time, do you have any IoT use cases that you might be able to share just to help everyone understand what industries you're going after and the kind of difference that you can make?
Yeah, a few of my favorites. We are working with, maybe 5 or 6 or 7 apiary companies now, so beehive monitoring companies, and I think this is a pretty special use case. All of our food comes from things that are pollinated. Most of that pollination is done by bees around the world, and I just think it's a nice synergy to thinking about Swarm. Swarm provides global coverage and it provides this communication anywhere in the world. Bees provide this pollination of food all around the world, and people want to know when a certain colony health is in trouble. They can monitor that with Swarm. I guess I've come to learn that a lot of these beehives are in remote locations that don't have cell. They put them in various locations for farming and agriculture and production. And sometimes if you're harvesting the honey, you want to know when that honey is ready within a couple of days or so, and you want to do that by a simple scale. So it's kind of one of these technologies where it's really hard to monitor that without satellite tools and technologies, and people have kind of been doing that in the past, but it's so expensive that it didn't really make sense. But with Swarm, it really does make sense, and so that's just kind of a cool technology that we can help the bees. Two of my other favorites are we deployed some devices in Antarctica when we deployed a ground station, and we are able to help some researchers take climate monitoring measurements down near the South Pole. And so that's pretty cool to be able to bring that data back in an effective way where they can scatter all these environment monitoring sensors all around and do that in a budget that works in the research grant. So we're pretty proud of that. Another one is monitoring water wells and boreholes in Kenya and Ethiopia, where Is the water well on? Yes or no? It's one bit of data that needs to come back. And if it's not on and it's not working, well, you want to send someone out there to fix it for the people that rely on that water source. And this is one of our favorite applications, actually, and it's done by a company called SweetSense that we've partnered with and helped out along the way. And they are using our satellite data modems. But that's a really cool thing. I think if people want water, let's get them some water with that one bit of data.
And what I find really interesting here is we seem to be, as a human race, thinking bigger than just using technology to download a box set faster on Netflix. And there's a big focus now on sustainability and using technology to solve some of the world's biggest problems. I'm curious, are you seeing much more interest in your technology now because of this big focus?
Yeah, every day that goes by, we find a new company doing a new application, and we never would have guessed it. When Sarah and I were pitching the idea of Swarm 4.5 years ago, we came up with a handful of applications that we thought might be interesting. The things like monitoring cargo containers on a ship, or the things like monitoring the location of a semi-truck on the road that's delivering some kind of freight. And these all exist, and these are normal things, and we're doing those. But every day we find something new, like monitoring beehives and, monitoring the noise of a chainsaw in a Brazilian rainforest so that you can send a ping back about illegal forestry. And geez, I really want to know about that to alert somebody. If that's going on in my world, let's tell some people. So it's just, these unique applications that I never would have guessed that kind of keep us excited about why we started Swarm, why we're doing Swarm, and what we hope to, even provide in the future, because it's a hard journey. And I think if your heart's not in it, that makes it all the much harder. But we really like, seeing these use cases and seeing what's enabled by what we're doing.
I love that. Absolutely brilliant. And for the techies listening that like to take a look under the hood and understand how all this works, my understanding is it's a combination of your unique small satellites and user hardware that delivers ultimately low bandwidth and data services. But can you tell me a little bit more about the technology that makes all this possible?
Yeah, sure. And it's also, one reason I think we've been successful is the architecture. A lot of people sometimes focus on the flashiest tech or the flashiest, highest efficiency, this or that. And I have a lot of colleagues and friends that, focus on those things and focus on the most extreme, technology. But I think Sarah and I have put together, hopefully, and the team, of course, have put together a system where the system works. You don't have to, worry about if there's a satellite overhead or not. We have a lot of satellites in space and they're working. And, to be able to do that, we made a lot of decisions to simplify wherever we could. So, for example, the Swarm satellites are the smallest commercial communication satellites in space right now. We stripped out a lot of the technologies that are typically associated with a modern day satellite. Some of these things like star trackers and reaction wheels and things like that. That really bulk up the size of the satellite, they bulk up the power needs of the satellite, and that bulks up the cost of the satellite. And I think, as far as I've seen, we've observed that other groups tend to focus on satellite systems that they might cost $200 million to deploy the whole network and the whole constellation, and that's neat, but at the end of the day, I think it's a question. Can you go out and raise $200 million? And probably not even that, probably $400 million, because everything is slower and costs more than you think, to support that whole endeavor. And usually the answer is no. And usually the journey of a satellite communications company is you raise a little bit of money, you get started, you launch some satellites, you have funding troubles, you go bankrupt, and then you try to start again. And I think the battlefield of that industry is littered with these folks that have gone bankrupt over time. And kind of noting on them, it's a hard game. But I think at least Sarah and I chose very early on to focus on a thing we knew we could actually build, and we knew that we could actually fund. And so that was sort of a key decision to how we decided to operate. But be that as it may, we also focused on making some advanced technology in our really small satellites, and we have over time iterated to a state of the satellite where it's about our 10th or 11th generation satellite now, where it's extremely robust to radiation, to any type of bit flip. We use a small microcontroller where we can't do all this fancy, 3 computer voting systems that people typically do in space. So we had to radiation harden it in other ways. We had to, develop a radio that was extremely sensitive. So we only transmit with 0.7 watts of power in space and 0.7 watts of power on ground with our ground modems. And that's like trying to communicate between LA and Chicago with garage door openers. Like, we're doing it and that works and it's actually quite reliable, but boy, that was tough to really nail. And the team did a really good job at coming up with a robust communication system with a lot of error correction, and being able to do these communications with that extreme of a distance. And now we even have customers where, because we were so conservative and so worried about this link budget, as people say, we have customers now that will even turn on their modems inside their apartment or inside their house in downtown LA or downtown San Francisco or downtown New York, and they'll get packets through. They'll get data packets through to our satellites, through their walls, through their roofs, to our satellites that are 2,000 kilometers away. And that's really interesting to see. So people sort of get a nice delight out of that. And we didn't make the system to work inside. That wasn't the intent. The intent was to enable all of these remote field applications. But I think it's just a nice property. It travels through some foliage, through leaves and trees, and travels through buildings. And it's nice to be able to have that robust of a system.
Wow, that's awesome. It really is. And on behalf of every techie listening that are used to going out and having to fix things when they go wrong, is there anything that can go wrong with a satellite or the 2,000 kilometers away? How do you maintain things like that? I'm just curious. That
everything can go wrong. Space is a very harsh and unforgiving environment. On the one hand, on the other hand, it's a very consistent environment. So, if you think about a car, that's a nice piece of technology that's been refined over many decades by a lot of people and a lot of money. But a car goes through these environments that are, on the whole, pretty extreme by themselves. They go through, deep freezes in northern climates. They have icing events. They have rain. They have, they go into a desert and they heat up to extreme temperatures. And it's just by a lot of engineering and a lot of thinking about this device has to survive in this environment over these, courses of this number of miles and years and so on, that people have been able to design for those use cases and design for those environments. And so, space is no different than that, but we don't all have the experience of, walking through the day and knowing what rain is and knowing what snow is. You experience that as a human, but you don't experience space, so it's a bit foreign, right? So you have to be a little mindful of what the differences are. And when designing a satellite, you have to be mindful of the vacuum of space. You need to make sure you use materials that don't outgas and don't evaporate over time, because you're in a vacuum, and you need to be able to use materials that are hardened to intense UV illumination from the sun, and you need to be able to make sure that you don't freeze in the night when you're in eclipse and you have no sun, and you're half of your satellite is facing the Earth, which is generally pretty warm, about 0 degrees Celsius on average, and half of your satellite is facing deep space, which is 4 degrees Kelvin, 4 degrees above absolute zero. So you just need to be able to make sure that your satellite components can survive all of that, sort of extreme temperature swing. You also live in a radiation environment, and radiation environment is pretty different than what we generally experience on the surface of the Earth walking around. So we do a lot of testing and a lot of experiments and a lot of qualification and acceptance tests in our lab and with a few partner laboratories, where we have custom chambers that simulate the vacuum of space. We have custom chambers and devices that simulate the full solar flux, and we have custom test rigs that measure and monitor the performance and output of each one of our components on our satellites. And I think because we make all of our satellites and we do all of the design in-house, we have an extremely close feedback loop to any part that fails because of temperature or fails because of radiation. Whenever that happens, we can design around it and choose either a new technology or a new chip that does survive. And because we're doing all of these huge number of experiments with this really closed feedback cycle, I think we've been able to arrive at this 10th generation satellite that's able to survive and function well in this pretty hostile environment.
And like I said a few moments ago, 10 million plus data packets sent across the Swarm network. But this is just the beginning for you guys. That's what I'm sensing here. So where do you go from here? What's next for Swarm?
Yeah, well, we'd like to see that, be 100 million data packets in the near future with a larger number of users. So, on the business side, we're focused on scaling. We're focused on increasing sales and hiring some additional folks to help on the sales side and help on the tech service side to answer customer questions and help them integrate modems into their products. So that's one thing we're doing. We will be completing the network, even though we're commercially live. We'll be completing the network this year, and that will bring our latencies down even further, so that we can have customers transmit and have a latency of about 1 minute. That's our goal. And as we look to the future, I think we see the costs coming down, and we see the data rates going up. Like any communications technology in history, that's just the trend of how things work. And we see that in a similar vein. So we have some aspirations for future programs and future constellations. We don't talk about those, but general themes are more data, lower cost, and easier integration into customer devices.
Excellent. Well, we began our conversation today talking about your origin story, but another question I like to ask my guests at the end of the interview is if there was a particular song or piece of music that has inspired them throughout their career, or maybe just helped you get your head in the zone before going on stage or in a big meeting. Is there a particular song that means anything to you that we could put on our Spotify playlist?
Oh, man. Maybe not related to the company, but I think Sarah and I joke all the time that we hire people with very high anxiety, and usually people take that with a negative connotation, but we take it with a positive connotation. We're fighters and scrappers, and everybody on the team has a high anxiety. But when I was a student, I had to channel that anxiety and calm myself down from time to time, and so I'd listen to "A Horse with No Name" by America.
Yeah, great choice.
Yeah.
Well, for so many years, I thought that was Neil Young as well.
Yeah, they're pretty similar. I had a playlist when I was working out in New Mexico, and I'd have these long desert drives, and I'd listen to "A Horse with No Name" and some Neil Young soundtrack.
Yeah, oh, brilliant. And before I let you go, for anyone listening that'd like to find out more information about Swarm Technologies, the work that you're doing, or contact your team if they'd like to work with you, what's the best way of doing that?
The best way is to email info@swarm.space. And if that doesn't work, you can email me at ben@swarm.space. The website is www.swarm.space.
Excellent. Well, I'll have those, the link to the website so people can find you nice and easily. And I love chatting with you today. It does seem that we're thinking bigger now than those faster speeds on Netflix and starting to solve bigger problems. And I just love listening to your stories of everything from hearing a chainsaw going in the Amazon to helping the bees and the role that technology is playing in all that. It's just so intriguing, and I'd love to stay in touch and see where it goes. But more than anything, thanks for joining me today.
Yeah, thank you, Neil. Really appreciate it.
Swarm's combination of uniquely small satellites, which are the size of a grilled cheese sandwich, and user hardware that delivers bandwidth a lot like 90s modem speed data services, because that is all that a lot of these IoT devices need, at the industry's lowest cost of 1/10 of the cost of a traditional data service and highest value to customers, is incredibly cool. Like I said at the very beginning there, they're making data and communications accessible anywhere on the planet for just $5 a month. But man, what a great story. So please send me any questions, emails, pictures to come on the podcast, whatever it may be. My door is open to each and every one of you. And my email address is techblogwriter@outlook.com, website techblogwriter.co.uk, Twitter, LinkedIn, Neil C. Hughes. I'm the easiest guy in the world to track down. So keep those messages coming in. I'll return again tomorrow. But thanks for listening. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.